Okay, so here we have another question. And once again, before you go anywhere, um, before you do anything or assume anything, always check to make sure that there is a GCF or there isn't a GCF. So because I have a 9 and a 16, I'm going to just double check. So a 9 breaks up into 3 times 3, and a 16 breaks up into 4 times 4, and then 2 times 2, and then we have another 2 times 2. So notice that there is nothing in common between the 9 and the 16. The 16 breaks up into 4 2s, and then 9 breaks up into 2 3s. So there is nothing in common, no GCF. Now let's take a look at the variables. We have x squared and we have y squared. There is nothing in common there either. So GCF has been checked for and there is no GCF. All right, so now we would take a look at what else could be happening here. So here I have a binomial and I have a minus. And so I'm going to look for difference of perfect squares now. I'm going to take a look at 9x squared first. Is this a perfect square? Well, 9 is a perfect square, right? That's 3 by 3. And x squared is a perfect square. That would be x by x. So this is a 3x by 3x squared. Let's check 16y squared. 16 is a 4 by 4. And y squared is y by y. So yes, these are perfect squares, and also make sure that there is a minus sign. Remember, if that was a plus sign, this would be non-factorable. But because it's a minus, it is a difference of perfect squares, and we can factor it. Okay, so as I said, we have 3x and 3x first, and then we have a 4y and 4y second, right? And remember that term in the middle needs to cancel, and we also need a negative product. So to get a negative product, we need a positive factor and a negative factor. So make sure you write a plus and a minus, and we are done.